Welcome to this introduction to the Trace Structures tool, part of the BuildChain platform, which enhances structural transparency and resilience through 5 specialized modules. In this video, we focus on the Hybrid Digital Twinning module, which enables efficient, real-time calibration and interpretation of finite element models in structural engineering by using surrogate models and Bayesian inference to synchronize digital twins with live sensor data and assess model uncertainties. This module guides you through defining uncertain parameters, sampling them, and evaluating quantities of interest using finite element models. It then builds fast surrogate models to replace complex simulations, enabling real-time digital twinning that syncs the model with the physical system. Using Bayesian calibration with MCMC, it updates input parameters while quantifying uncertainty. The module offers interactive visualizations of parameter distributions and sensitivities, performs sensitivity analysis with Sobel indices, and explains model predictions through SHP attributions. Plus, it integrates seamlessly with the BuildChain DKG for enhanced data management. Ready to explore the Trace Structures API? Head over to buildchain.ilab.SZTAKI.hu to get started. Then, go to the Hybrid Digital Twinning section to either start with a new model or load an existing one, or simply explore the tool using built-in demo data. You can import pre-trained models by clicking the Input Loader button. This lets you upload a file from your computer. Alternatively, you can import models through the DKG API. If you click on the Next button or navigate to the next page on the menu bar, you can start creating your parameter set. To add a new parameter, click the Add Parameter button on the left side. This creates a new empty entry in the parameters table below. Click the Edit button next to a parameter to open a window where you can change the parameter's details. To set specific limits or statistical properties for your input parameters, click Optional Settings. After you finish, save your changes to update the table. Click Save to File to save your parameters as a JSON file. This file can later be used to reload parameters using the Choose File button. On the next page, you can configure the sampling settings. You need to choose a sampling method. Select the number of samples and optionally set a random seed for reproducibility. Click Sample from parameters set to generate your samples based on your chosen configuration. When finished, save your results by clicking Save Samples and Sampling Setting. This exports samples as CSV and settings as JSON. To use previously generated samples, click Choose File and select your file. Run simulations offline at each sample point to compute your Then Q you have to values. import measured structural After simulations, use upload the your input results by loader to clicking upload measured Choose data File in in the JSON, quantity of UNV, or intersection. CSV format. The system will display basic Alternatively, you statistics can about your import these quantity of measurements from the interests. DKG API. When everything is done, you can click on the Next button standard to move to deviation of data measurement error can exploration. be included the same way. Here you can visualize relationships and correlations between parameters and quantity of interests. Adjust scatter plots to show your preferred variables on the X and Y axes. Optionally, color your plots by a third variable. Train surrogate model. Set up your surrogate model by choosing how to split training and test data, selecting a model type and setting up the model's hyperparameters. Based on what type of model you've chosen, you need to set different hyperparameters. Once you've finished, you can click on Train Model button to start the training. Once it's finished, you can save your model locally or upload it to a knowledge asset using the DKG API. You can also view detailed statistics displayed below, including averages as well as individual values for each quantity of interest. Here you can analyze how input parameters influence model outputs using statistical summaries, mean and variance, global sensitivity analysis, Sobel indices, feature importance, SHP values, local feature explanations for specific samples, After uploading the measurements, you need to link quantities of interest with measured variables. If they have the same name, they will automatically get linked. If not, you can click on the dots to link them. On the next page, we can start the Bayesian updating of parameters. You need to configure the MCMC sampling algorithm by selecting several key settings: number of walkers, the burn-in steps, and post-burn-in steps. Then you can click on the button to begin sampling. Once sampling is completed, you can see a paired matrix plot comparing the prior input parameter samples with those sampled from the posterior distribution. It also shows key point estimates such as the posterior mean and the maximum a posteriori estimate. You are able to save these statistics and the posteriori samples. This concludes our overview of the hybrid digital twinning module in the Trace Structures API. For more detailed guidance, examples, and advanced use cases, you can find the full documentation directly in the interface or at the Trace Structures platform website. We also invite you to explore the other modules, such as data-driven modeling, multi-building design updating, earthquake, and climate resilience analysis, to discover how Trace Structures enables smarter, data-driven building management throughout the entire lifecycle.